We had a session tonight or not. But
Yeah.
if you don't get your text messages, that's a problem, isn't it?
Yeah.
All right. So let's see. What are we going to do tonight?
I have a review packet.
Okay.
And I have quite a few problems from that we can go through.
Okay. Can you verbalize them?
Yeah.
Okay.
So, this one confused me. It said, assume that y is directly proportional to x, then x equals 16 and y equals 12. Determine a linear model that relates y and x.
Okay. All of these direct and inversely proportional problems play out the same. Your first step is to figure out what k is. Okay. For direct relationships, y equals kx. For inverse, it's y equals k over x.
All right.
Since they said this is direct, we're going to plug in the x and y that they gave us. 12 equals k times 16. Solve for k. K equals 3/4. Now we have the specific. This is called the general. Now we have the specific equation.
Okay.
And regardless of how they express the problem, almost every one of them plays out like this, is they give you enough to let you calculate k.
All right. I think I have another one similar to that.
Okay?
It says, find the constant of proportionality for the following situation.
Okay.
Y is jointly proportional to x and z and inversely proportional to w.
That's what that means.
Mm-hmm.
When it says y is jointly proportional to x and z, then I can write the numerator immediately.
Okay.
And inversely proportional to w, that means it goes in the denominator. And sometimes it's like inversely proportional to the square of w. So it doesn't always have to be linear.
Okay.
Gravity, the force of gravity is inversely proportional to the square of the distance between the two objects.
Mm-hmm.
Okay? So again, they're going to give us probably a y, an x, a z, and a w, and we're to calculate k.
All right. Should we do that?
Sure. Well, go ahead and read the rest of the problem, and then we'll see whether we need to go into it or not.
W equals 9, x equals 3, y equals 1, z equals 4. X equals 3, z equals 4.
Yeah, they have to give you, not just x, z, and w, but also y. And then you solve for k, and you end up with the specific equation, which is y equals some number times x, z over w.
Okay. And then, okay. And I've always had trouble with these. It's the symmetry.
Okay.
Test.
Uh-huh.
And the equation is x over x squared plus 1.
And we're to determine whether this is even, odd, or neither?
I think it's to determine whether it has y-axis, x-axis, or origin symmetry.
Okay. Y-axis symmetry means it's even. Odd means origin symmetry. And x-axis, that isn't really measured by even or odd, but even symmetry means f of minus x is equal to f of x. Odd symmetry means f of minus x is equal to minus f of x. And x-axis symmetry means that it means minus f of x. In other words, if y equals x squared, x-axis symmetry would be y equals minus x squared. So, with those regards, let's look at this function here. So, if this is f of x, then let's figure out what f of minus x is, and that'll tell us a lot. What is f of minus x?
Just negative x over, it would still be x squared plus 1.
Which is minus x over x squared plus 1, which means that's equal to minus f of x. You get each of those steps?
Mm-hmm.
So since f of minus x equals minus f of x, we have origin symmetry. Yeah, and we don't have, in other words, I'm not quite sure. X-axis is not really, it's a symmetry, but it's not like a function has symmetry about the x-axis. Y equal x squared, that function has even symmetry, meaning that f of minus x is equal to f of x. So that's what tells you that this is an even function and it has symmetry about the y-axis. Okay, you have another one? Because I'm dying to get to the one that has x-axis symmetry.
No, there's no more of those kinds of ones.
Okay. Now, just to be clear, that is y equals square root of x. The symmetrical function is y equal minus square root of x. So this is f of x, so x-axis symmetry is always minus f of x. All right.
So this one says, a rectangle is bounded by the x-axis and the semicircle y equals root 81 minus x squared.
Okay.
And write the area of the rectangle as a function of x and determine the domain of the function.
Is that a correct picture?
Yeah, there's another box on the other side of the x-axis, or of the y-axis.
Okay. So that's the rectangle. Okay. And this is the equation of that semicircle. Notice that the negative side of that makes the circle. So the equation is y squared plus x squared equals 81, so it has a radius of how much? In other words, if I square both sides here, I get y squared plus x squared equals 81.
That would be 9.
Okay. So that is a radius, since the center of that circle is at the origin, so we know that's 9.
Mm-hmm.
Now, what was the rest of their question?
Write the area of the rectangle as a function of x and determine the domain of the function.
Okay. So the area of this rectangle as a function of x is going to be 2y times 2x, which is equal to 4xy, but they want it as a function of x, so we have to turn the y part into a function of x. Well, use the Pythagorean theorem to do that. What is y equal to here? Actually, it's the same as that. Right? In other words, one side of a right triangle is equal to the square root of the hypotenuse squared minus the square of the other side. So if I plug that in, then I don't have y equals this. I have 4xy equals 4x times 81 minus x squared. And 4xy is the area. So area as a function of x is that.
Okay. Then what would the domain be?
Of the area. Okay, so we're looking for the domain of 4x root 81 minus x squared. So how do we figure out domain when we have restrictions on it?
I'm going to find out when x...
well, the best way to do it is to take whatever's inside the radical and say that that has to be greater than or equal to 0.
Yeah.
It can be 0, but it can't be negative. So let's see. First of all, you want to help me solve this?
It'll just be x has to be less than 9, or less than or equal. No, yeah, less than or equal to 9.
Is that it? How about or greater than negative 9? In other words, it actually has to be in that range right there. Any x, in other words, minus 8 works also. So that's the domain of x, from minus 9 to plus 9. But when you have domain problems like that, and you have a complicated expression inside the radical sign, then just create a separate equation, or not equation, but an inequality that you then have to solve. Now, let's go through how we solve that inequality, because you kind of did it intuitively, I could tell. But let's go through how we algebraically do it. Let's move the 81 over. let's divide both sides by -1, meaning I have to turn that around. Now, the way to solve that is, well, clearly x is less than or equal to 9, but the other half of that is x is greater than or equal to that. Always both ways when you take the square root of each side in an inequality. It's not obvious that this way you're dividing by a positive x. This way is the equivalent of dividing both sides by a negative x.
Yeah.
Notice that I turn both the direction and change the sign. All right.
Okay. This problem is graph the function and determine the intervals for which f of x is greater than or equal to 0.
Okay.
And the equation is f of x equals negative x squared plus 3x.
I'm sorry, what was the rest of it?
Plus 3x.
That's it?
Yeah.
Okay, so we want to graph the function and figure out where it's greater than or equal to 0. Which do you want to do first?
Graph it.
Okay, to graph it, we probably need to do what we need to do to figure out this part here also, which is to factor that. Let's factor it like that. Now, if we want to know where this product is greater than or equal to 0, we need to do a line chart. Yeah, I might be able to graph this straight away as a parabola and solve it that way. But let's talk about this, because you need to know how to do line charts when you have an inequality. When you have a product of two linear functions greater than or less than 0, you need to know how to do that. Or a quotient of one linear function divided by another linear function. Is this, you've done this in class, finding critical points?
Yeah, we just did that recently.
Okay, what are the two critical points here?
0 and 3.
So those are the only points I'm going to put on the, if 0 wasn't a critical point, I wouldn't label it. Now, take a number to the left of your furthest left critical point, plug it in and see whether you get positive or negative. And that's all we care about, whether it's positive or negative. So plug in -1.
You have 1 times...
That's plus. That's negative. That's all. I don't even care about what the number is. It's just a plus times a negative, which means every point to the left of 0 is negative. Now plug in a point between 0 and 3.
1.
Okay, so this is negative, and this is negative. Negative times negative is positive, which means every point there is positive. And then the final step is a point to the right of 3. That's obviously negative. That's positive. Their product is negative. So the answer to the question is this interval right here is where x is greater than or equal to 0. Now to graph it, this tells me my x-intercepts. I have to have an x-intercept at 0 and 3.
Mm-hmm.
This tells me that it opens down.
Yeah.
So I know that it has to look like that. I don't know how high up it goes, but they didn't ask. Although that certainly is a key point of this parabola, is the vertex. So in a way, I guess we do have to figure out the vertex and where to graph it. Well, we know it's halfway in between, right?
Mm-hmm.
So the only question is do we have a parabola that looks like this, or do we perhaps have a parabola that looks maybe like this?
Mm-hmm.
So to really graph it, we really do need to know the y-coordinate of that vertex. So how do we get that?
I'm not sure.
This x-coordinate is 1.5, halfway between 0 and 3.
You just plug that in.
Plug in 1.5 into this function, if you like. So we have minus 1.5 times minus 1.5. That's equal to plus 2.25. So the peak, if this is it, that's 2.25. So now we've graphed it as well as we can graph it. We've got the vertex, we've got the coordinates of the vertex, and we've got the x-intercepts. We know everything there is to know about that parabola. And that also shows us, had we graphed it first, well, we can just tell that it's above the x-axis from 0 to 3. So that would have told us, we wouldn't have had to do this if we would have graphed it first. So I didn't really need to do the line chart, but I did need to factor it. That allowed us to graph it. Once we graphed it, we would know the answer. But it's worth knowing how to do that line chart. That line chart's going to come in handy if you have a problem like solve this. If I said to you, solving that is difficult without using line chart analysis.
Mm-hmm.
It's not obvious at all like it was with a product and an inequality.
Yeah.
And this was presumably no calculator here?
Yeah.
Okay. Because with a calculator, it's easy. You just plug it in and you look where it's above the x-axis.
Yeah. This one says simplify I to the 507th power.
507?
Yeah.
Okay. What's I squared equal to?
-1.
What's I cubed equal to?
I forget.
Well, I cubed is I times I squared. So what would it be?
You just root -1 again.
Negative I. And I to the 4th?
The I squared again.
Which is? It's I squared times I squared, right?
1.
So it's 1. Okay, how long's our session? An hour?
Yeah.
We'll get there. What's I to the 5th?
Positive I.
And so forth and so on. So that, if I said, what is I to the 28th, what would you do?
You just find I to the 20th.
You divide this by 4.
Mm-hmm.
So I to the 28th is the same as I to the 4th.
Mm-hmm.
It's just I to the 4th to the 7th. And I to the 4th is 1. So I to the 28th has to be 1. That means I to the 29th would be I. In other words, if you divide this by 4, you take your remainder. In this case, it's 3. So that is the same as I to the 3rd.
Okay.
Let's see. Let me just make sure I'm right there. 504 would be the same as I to the 4th. So 505 would be I. 506 would be I squared. 507 would be I cubed. Yeah. You take the remainder, and that's the exponent for I. So that answer is I to the 3rd. The key thing to know is that it repeats every 4.
Mm-hmm. Okay, this one says if f of x equals negative 4x squared plus 2x minus 5, use synthetic division to evaluate for for f of negative 8/7.
Okay? And we're going to set this up.
It's going to be negative 8/7 on the outside, and then on the inside it will be negative 4, 2, and negative 5.
What goes here?
Negative 4.
Why would they give you such a tough problem like this?
Then,
Okay, what goes here?
Negative 36/7.
It's 32/7, and it's positive.
Yeah.
This times that is 32/7.
Yeah.
And I'm going to change that to a proper number. Let's change the 2. Hold on. The tablet's been giving me problems lately. Okay, so in order to add these, let's make this 14/7.
Mm-hmm.
So that gives us 36/7. Gotta be kidding. Why would they do this to you? This is non-calculator problem?
I think so.
Okay. So, it's not even anything you can shortcut cancel. It's straight multiplication. So this is minus
Well, maybe
24, 288/49. Well, that's as far as we need to go. Why?
Yeah.
Because their question was determine if that is a 0 to that.
Mm-hmm.
And all you have to do is prove that you get 0 there. It is. Anything else, it is not. Mm-hmm. And so I don't have to simplify that. I know that that plus a negative 5 is not 0.
Yeah.
All right. I forgot to look at it in context of what they were asking. It wasn't so hard after all. You know how to do synthetic division with imaginary numbers? Have you had that?
Yeah, I think we did one of those.
Okay. It's straightforward. You do it exactly as you would think.
Mm-hmm.
Okay.
I can't find any. Do you have like an example of one?
I could make one up. 2 minus I. If we divide that into 4x squared plus 5x plus 10, and see if it's a factor. Now multiply that, so we get 8 minus 4i. Add those two together, you get 13 minus 4i. Multiply those two together, and you get 26 minus 13i minus another 8i is minus 21i plus 4i squared, which is minus 4. And now you add that to 30 or 22 minus 21i. In other words, I can take that 4 away from that. And so when I add these two together, I get 32 minus 21i. If that was a solution to that quadratic, I would have gotten 0.
Okay.
Same thing with irrational solutions. I wanted to divide it by 2 minus square root of 3. Same thing as I just did with I.
Alright, my next problem is, in the graph of the quadratic function f of x equals x plus 7 squared plus 1. Determine the equation of the axis of symmetry.
Okay. What is the standard or vertex format for a quadratic? The general one.
Just ax squared plus bx plus c.
You know, this actually is, this is the vertex format. The standard format, which you just gave me, I've heard other people say this is the standard format also. So I'm not real sure what the standard format is, but I meant the vertex format. Because if we have it in vertex format, then we know where the vertex is. And that's what this asked for. Oh no, this asked for the axis of symmetry, which is merely the x-coordinate of the vertex. The axis of symmetry is the vertical line x equal h. So what is h in this formula?
Minus 7.
Yes. H equals minus 7, so the axis of symmetry is a vertical line at minus 7.
Okay, that's pretty simple.
And the thing looks, let's see, the y-coordinate is at plus 1, so it actually looks like that. Yeah, if you can know all the formats, the only other key format for a quadratic is the x-intercept format, which is this, where P and Q are the x-intercepts. So if you can start with a function, depending on what they ask, if they ask for the x-intercepts, then we'd want to put it in this format. If they ask for the vertex, we want to put it in that format, or the line, the axis of symmetry. If they want to know something else, it might be worth putting it into standard format.
Okay. All right. This one says write x cubed plus 4x squared plus 3x minus 5 in the form f of x equals x minus k in parentheses times q, then times x, then plus r.
Like that?
The q doesn't have parentheses, and the x does, but that's when k equals 1.
The r is separate. The r is not inside the parentheses?
No.
When k equals 1.
And it gives like A, B, C, D, and E as answers. And they're like x minus 1 times...
Well, all right, I get what they're saying now. This means q of x.
Oh, okay.
That's like f of x, only it's q of x. All right, when k is 1, that's the same as synthetically dividing that by 1.
Okay. Oh, and then you just convert it to vertex form, probably.
Well, no. The remainder that we get, that will be this part, and the remainder will be this part.
Okay.
Okay, so let's do it real quick. I know I'll do it. I know you know how to do this, so super. So, what is q of x? So in other words, my final answer is f of x equals x minus 1 times, what's q of x?
1, or just x squared plus 5x plus 8.
And the remainder is written how?
3 over whatever you divide by, so 3 over 1.
Which was what here? X minus 1. In other words, it's important to know that when we synthetically divide by 1, it's the same as having a divisor of x minus that number. So this is what they're looking for, as a solution.
All right. And the next one is, these are really tough for me. It's, I forget what they're called. They're like a bunch of numbers inside of brackets. Like columns and rows.
Sets?
I think
or matrices?
Matrices.
Okay.
So this one says, evaluate the determinants.
Okay.
Of e to the 2x is top left.
E to the 2x?
Yeah.
Okay.
Top right is e to the 3x. bottom left is 2e to the 2x, and bottom right is 3e to 3x.
Okay. The determinant of that is A times D minus C times B.
Okay.
Okay? A 2 by 2 is always that. It's the left, the negative diagonal with the slope negative, the product of that minus the positive product. So in this case, AD is that product, which is what?
3e to the 5x squared.
Just 5x. 2x plus 3x is 5x.
Okay.
Not multiplying. If we were multiplying them, it would be 6x squared. Okay. Minus that product.
2e to the 5x.
That simplifies to
just e to the 5x.
Yeah, I got 3 apples minus 2 apples, 1 apple, with my apple being e to the 5x.
So it's actually a plus d minus c plus d.
What's that?
It's actually, like, in the equation, it's a plus b minus c plus d.
No, this is multiplied. So to find the determinant, it's a times d minus c times b. It just looked like addition because we ended up adding the exponents.
Yeah.
But we were actually multiplying. I multiplied e to the 2x times 3 to the 3x in order to get 3 to the 5x. And then if you have higher order matrices, it gets more complicated to figure out that determinant. Have you had to do 3 by 3s yet?
Yeah.
Want to go through that?
Sure.
A couple of methods for doing this. The one I like the best is to create 2 more ghost columns. The first 2 columns repeat. Now what we essentially do is take the product of those 3. So A times E times I plus the product of those 3 plus B times F times G plus the product of those 3, C, D, H, and we subtract out. In other words, it's a similar pattern, only it's a little different. We subtract out the sum of those. H, F, A plus I, D, B. And it's important to use this bracket because notice this subtraction sign is always going to be applied to all 3 terms. So use a bracket or parentheses and then perform that first before you subtract it.
Okay.
And so whatever numbers you want to put in there, that's going to be the determinant of that 3 by 3. And I suppose a 4 by 4, you'd do the same thing. You'd probably write 3 ghost columns.
Okay, and have you done like decoding cryptograms?
You know, I I remember reading that in the chapter on matrices, and I didn't do it. I mean, it was really hard for me. And to tell you the truth, you are the first, maybe the second student in 5 years that has ever brought it up. So
Yeah, my
I can,
teacher's kinda-
do we have another session before tomorrow? Or is this our last session, or we got one more?
I think we have one more.
I can take a look, and we can talk about it at the next session. I don't really know it well enough right now to do it,
Okay.
and we only have like 7 minutes, so it's probably worth looking at something else and then talking about that tomorrow or whenever our next session is. I'll take a look at it and see if I can figure it out. It is kind of fascinating. I do kind of remember understanding their process, so I think I could explain how an example works, at least. I'm not sure I could do a problem from scratch, but maybe I could. I'd have to look at it a little bit. I'll refresh myself on that.
I'll just go to a new one. So this one says solve for x in the equation given.
Okay.
4x equals 4a minus b, and A is the matrix 7, negative 7, 4, 2. 7, then so, yeah. And B equals 44, negative 16, negative 4, negative 12.
Okay. These are all, this is just a scalar. So 4 times A would be 4 times every entry there. 28 minus 28, 16, 8. Negative B, I'm just going to write B the same way it was, because it's, now I'm going to subtract individual entries. So what do I get? I get, I'll write it over here. So I get 4x is equal to minus 16, no, minus, minus 16, minus 28, minus a 16 is minus 12, 16 minus a minus 4 is 20, and 16 minus a minus, 8 minus a minus 12 is 20 also. Did I do that right?
Yeah. So.
Now I can divide both sides by 4 so that my final answer is minus 4, 5, minus 3, 5.
Okay.
So that's what x is equal to. The x matrix is equal to that. No, that's a vector, excuse me. All right. You had to do augmented matrices yet? Or are we going to get to that?
I'm not sure.
Okay.
What is an augmented matrix?
Oh, it's one that looks like this. There's a vertical line, and maybe this would be minus 1 and 4, and you might have a 0 there and a 9 there.
Oh yeah, we've done that.
It's basically a way to solve simultaneous equations and variables. In other words, it's easy to solve 2 simultaneous equations and 2 variables, but the more equations and variables you have, the far more difficult it is to solve manually, the way we're used to solving it. Whereas with matrices, you can have 11 equations and 11 variables, and you just set up an 11 by 11 matrix, and it's much easier to solve when you're using matrix algebra.
I think I have one of those, actually.
Okay, well, we don't have time for it tonight, but
Okay.
we can do it tomorrow night. Those can be a little challenging to understand.
All right.
Got any, why don't we go ahead and quit now. I have an 8 o'clock, so that will not make me late for that 8 o'clock.
All right.
Okay, and our next session, let me just check here, is Wednesday night, but just for a half an hour. Is that going to work?
Yeah, that's all I could get in, I think.
Okay. I will talk to you then, and I'll try to take a look at this crypto. You think that's going to be on the test or not? Is it something we should spend our time on?
Yeah, my teacher's kind of weird, so he'll probably put it on.
Okay, we'll do it.
And I'll see if I can get another session tomorrow night if it's not all booked.
Well, as you can see, I am jammed solid.
Oh, yeah.
Monday I got nothing open. Tuesday I could sneak you in somewhere, like maybe at 3:30, or I don't. You don't get out of school that early, so it's tough. This is my toughest 10 days of the year in terms of being busy.
Yeah. All right.
Okay.
Okay. Thank you.
All right, Griffin. Talk to you Wednesday. Bye-bye. Oh, by the way, Griffin.
Yeah.
Did you check that file? I did change it from private to public.
Yeah, I got it.
How it got changed, I don't know. Every one of those I upload to YouTube, I upload as public. And every now and then, randomly, a bunch of them get changed to private, and I don't know how it happens. I have to manually go in and switch them back. Once they changed all my files on my website got changed to private, which was a disaster until somebody told me about it, and then I was able to go change it. But, all right.
Yeah, I got it.
Talk to you later.